When I say that what I just told you went out the window, that means we have two different methods for calculating ideal mechanical advantage with pulleys. Now, this is a very different setup with separate strands. Once I see separate strands, we do something different. Fixed pulley has a mechanical advantage of 1. Think of that fixed pulley. I drew a lever right here. Commonly we have one person on this side of the seesaw, one person on this side. That would be a mechanical advantage of 1. You can kind of think of it that way. Movable pulley, a rope goes through something like this and it lifts up and it's pivoting out on this end. So it has a mechanical advantage similar to that of a second-class lever. It has a mechanical advantage of 2. What we do is we multiply the mechanical advantages of each of the pulleys together. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, plus this fixed one is 17. Let's do a little practice. Single strand, don't count this one, mechanical advantage of 1, 2, 3, 4. This one, similar to the last slide, so mechanical advantage of 2 for all of these except for this one, which is 1. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, plus 1 is 33. Also, before we leave pulleys, let's go back. Let's go back to this slide. We never talked about AMA, and AMA is really straightforward. The equation is still the same. AMA is Fout over Fin. My Fout is going to be my load. Maybe I have a load right here, and it's 15 newtons, and maybe I'm pulling with 5 newtons. And when I pull with that 5 newtons, that would be my fin, my force in. So I didn't mention that, but that equation stays the same, and that's pretty straightforward. Fout is always your load, fin is always your force in. Okay, let's say this is an activity you guys are going to do in class. All right, let's talk inclined plane. Inclined plane. AMA, we'll start off with that one. AMA, Fout over Fin. Maybe I have a force of 15.23 pounds, and I'm pushing in with 2.3 pounds. 15.23 over 2.31. 6.59, Fout over Fin. Let's talk din over doubt. Let's talk IMA for an inclined plane. The din, the distance in, think about it, the distance you're going to input. Distance you're going to input is going to be along the hypotenuse of the triangle or along the angled part of that ramp. Your doubt, what's the output of an inclined plane? What's its job? Its job is to output this distance. So this distance where I'm drawing right here, the far side, the height of the ramp is your doubt. So din, the length of the ramp, doubt, the height of the ramp. IMA, din over doubt. Last one. Let's talk about screw. Couple things we need to know. You're going to commonly see, just like this red circle, some nomenclature we need to go over. You're going to commonly see quarter 20 NC, or some measurement, and usually 20 and usually NC. The quarter stands for the diameter of the bolts. The 20 stands for the TPI, we call it, or the threads per inch. And NC stands for the thread type, or national course. Quarter 20 NC. Our equation is very different. Our equation for IMA is circumference, C stands for circumference, divided by 1 over TPI. IMA equals, don't forget that circumference is pi d. So pi, and my diameter was a quarter, so pi, 1/4, or pi 0.25, divided by 1 over 20. 20 was my threads per inch. Gives me a mechanical advantage of 15.7. AMA would be the exact same equation, Fout over Fin. Maybe I'm pushing in or pushing with a wrench with X amount of force, that would be my fin, and maybe the force or the screw is being driven down with some force, that would be my Fout. Before we leave the slide, let's mention, what if I put a wrench? If I put a wrench on this slide, or excuse me, I put a wrench on the screw or bolt right here, what I really did was I elongated I just changed the diameter. So what's going to change is just this part is going to change in your equation, just the diameter. So, but what we need to realize is if I put a wrench, let me redraw that. If I put a wrench, maybe it's this long, this is only the radius. This part's only the radius of the circle. Because I'm going to spin my wrench all the way around, let's say the wrench is 15 inches long, but my diameter is actually 30. Does that make sense? Because I'm spinning that wrench around. A 15-inch long wrench has a diameter of 30. So I'll take that measurement and plug it in here. That's the only part of the equation that's going to change. Instead of pi 1/4, mine would be pi 30 with a 15-inch long wrench. That will increase my mechanical advantage drastically. Okay, last one, wedge. All we really need to go over are our measurements. Let's do IMA first. IMA, din over Dout. The distance I'm going to input my wedge. Wedge could be scissors, a knife, an axe, or a hatchet. So din is the distance I put in, the length of the wedge. And the Dout is the distance out. What is the point of a wedge? Let's use a hatchet. The point of it is to split something. What distance? This distance. That's my measurement for Dout. Let's talk fin. AMA, Fout over fin. The fin, the force in. What force am I going to drive down this hatchet? And then force out, how much force is going to be pushing out on either side.